Alright, we're going to complete the square with algebra tiles and the symbols. And hopefully I'll show you why some of this stuff works with the algebra tiles. It's kind of a neat little exercise we're going to do. I'm going to show you the the algebra way, probably the way your teacher showed you how to complete the square. And he probably told you, he or she probably told you just to memorize a bunch of steps. And it's the same thing I do. But it's neat to do a little exploration. But before we get started, I want to show this site. This is Algebra Tiles CPM, CPM Educational Programs. I went ahead and just Googled Algebra Tiles, APPLET, and this is one of the sites that I found that works pretty good. And you just click on this Algebra Tiles CPM, and it gives you this nice little place to work with algebra tiles. And so I'll show you how we'll do these and show you how it works kind of as I'm doing this. So, but first I'm going to give you the way your teacher taught you. All right, so the way your teacher taught you is the first step. So here's our quadratic. X squared plus 6x plus 5. So your first step then is, they probably told you to move 5 to the right. So we'll subtract 5 over. And so you'd have x squared plus 6x equals negative 5. And you might have had a box here in this spot, or I tend to just leave it blank. Because you're going to do some freaky thing that you don't understand, and your teacher just says, just do it, memorize it, just make it happen, and who cares? As long as you can do it, I'm happy. It's no different than the way I've taught it at times. So anyway, you take that 6, that middle term, and you divide it by 2, 6 divided by 2, and you square it. And so when you do that, 6 divided by 2 is 3, 3 squared is 9. So what you're going to do then is add 9 to both sides of this equation. And so you have x squared plus 6x plus 9 equals negative 5 plus 9. Well, you'll notice here on the left, that factors into x plus 3, x plus 3. And on the right, negative 5 plus 9 is 4. And so if you go ahead and combine something, x plus 3 is actually x plus 3 squared equals 4. And you'd keep solving. But I'm going to show you a step that you normally wouldn't do, just so you can see, you'll be able to see it when I do the algebra tiles. So this is x plus 3 squared, and what you could do is you could subtract the 4 to the left. And so it would be minus 4 equals 0. This part here is going to literally become a square. And that's why it's so important that I show that to you. That's what we're looking for when we use algebra tiles, because we will have completed the square properly when we see that. So the next thing though that you did, let's go back to this step before I move that 4 over unnecessarily. But we had x plus 3 squared equals 4. You then would root to get rid of the square, and you're left with x plus 3 equals plus or minus 2. And then your teacher said, go ahead and subtract the 3, and your answer is x equals negative 3 plus or minus 2, x equals negative 1, x equals negative 5. And again, how I did that, I'm kind of skipping some steps because I want to get to algebra tiles. Negative 3 plus 2 is the negative 1. Negative 3 minus 2 is the negative 5. This plus or minus tends to be some confusion too. And why that is, that's a different video for a different time. But let's go ahead then and do the algebra tiles now. So first off, x squared plus 6x plus 5. Let's see what that looks like in the algebra tiles. The main thing is x is just a length. So if you notice, I'm just adjusting the length of this this size x. It could be 2 inches or 3 inches, whatever. It's a number that can change, and it's nice to think of it as a length. And if you multiply a length and a width, you get an area of x squared. If it's the exact same length on both, it's just x squared. It's that length squared. And so we need, I gotta look back here, we need we need x squared. So we'll pull an x squared. We need 6 x's. So I'm just going to stick them here. 1, 2, 3, 4, 5, 6. Yeah, there's 6 of them. And then we also need 5 individual units, which are right here. Unit tiles. 1, 2, 3, 4, 5. Okay. This 6x here, oops, we try to highlight them without getting the x squared in there. Oh, can't do it there. Do it that way. So all those in yellow, those 6 x's, that's your middle terms. So we're going to divide those in 2. So let me divide those in 2. So there's 6 of them, so I'll do 3 here and 3 here. And not only am I going to divide them in 2, I'm going to go ahead and turn them on their side. So I'll double click and turn them all on for one of them. And here's what happens. So I can go ahead and set those in here. Let me get these out of the way. And split them in half. Okay. Notice I divided them by 2. And it creates a 3 by 3 square, or you'd have 9 individual little blue squares if you stuck these in here. You would have 9 of them. Remember, I only started out with 5. So if you could imagine, and let me see if I could draw these in here. If you could imagine here, oh yeah, it's going to let me draw them in. I just divided it by 2, and now I'm squaring them, creating 9 squares. Well, take a look at when we did that. We took 6 divided by 2, and we squared it. 6 divided by 2 is 3 on the top, 3 on the side. You square it, and you end up with 9. And that's what we added to both sides of the equation. There is that 9. I added there and there. Okay, so that's the first step on your path to understanding this. So let me get rid of those because we don't need them. Okay, now let's arrange these tiles in here. And notice when you arrange these in here, it doesn't fill the whole space. Notice this is pretty cool, I think. There are 1, 2, 3, 4 spaces missing to make that 9. To make that 9 we need with the 5 we have. Well, if you think of this, now we have a square. If you look at this, that is a square now with those 4 empty spots. Well, this side of the square is x plus 3. This side of the square is x plus 3, but we're missing 4 chunks. So we're minus 4 from making a perfect square. So this is a square of x plus 3 squared minus 4. And there you have it. There is your square completed. And so if you take a look at this, there that is. X plus 3 squared minus 4. And so that's the completing the square part. That's the essence of completing the square. Now the rest is just, some algebra tricks to get to the answer. But that is how you can show that it is actually completing a square. So let's do it on another example. So you've got x squared minus 2x plus 4. So this one's just slightly different. And if you did this problem, you would, tell your students to subtract 4 from both sides. You'd have x squared minus 2x equals negative 4. Then you take that middle term, which is 2. We're going to divide it by 2 and square it, because that's what you do every time. Divide by 2 and square it. Well, 2 divided by 2 is 1. 1 squared is 1. So we're going to add 1 to both sides of the equation. So you'd have, now notice, that on the left factors to x minus 1, x minus 1, and that equals negative 3. So our completing the square part yielded us x minus 1 squared, and if you add the 3 over, plus 3. Well, that means we're going to have a square of x minus 1, and we're going to have 3 tiles left over if we show this with algebra tiles. And I'll go ahead and keep finishing this out. So you got x minus 1 squared equals negative 3 if you move that 3 back over. I'm going to box this in so when we check it with algebra tiles we can see. And then you'd root both sides. Let me change colors. Getting sick of red. And so you have x minus 1 equals plus or minus the square root of negative 3. Well, I don't know if you know anything about imaginary numbers, but this becomes plus or minus I root 3. So x, and then you'd add 1 to both sides, and you can't really combine the real and the imaginary because now it's a complex number. So it's x plus or minus I root 3. Or x equals 1 plus I root 3, and x equals equals 1 minus I root 3, sorry. So there's your two answers. We usually just represent it with one set of symbols and use the plus or minus. Okay, again, the answer isn't necessarily what I'm after, but maybe somebody caught this video on accident on how to complete the square. I mean, we're really after this bad boy. And so if we try it out, let's go ahead and go back to my algebra tiles. And let's get a brand new set here. And we'll get rid of the old stuff. And we need an x squared. So I'll put that tile out. We need negative 2x's. And what's kind of cool about algebra tiles, let me pull this up so we can get there. We need that negative 2x. And so what we'll do is with algebra tiles, we'll pull up 2 just regular old algebra tiles. And what's cool is if you double click or just single click on them, you get a negative x. Okay, and so we've got our 2 tiles, and we need, I think, 4. We need 4 singles. So let me pull that up. 4 singles. 1, 2, 3, 4. So we've got x squared minus 2x plus 4. And we'll split the middle term. Here's my middle term. There's my negative 2x. We'll split it in half. Put 1 here. Put 1 here. And square it. And notice we only need 1. It only makes a 1 by 1 square, so we just need 1. And we have 3 left over. And if you did the same thing we did last time, this is a length of x. This is a minus 1. This is a length of x. Minus 1. Wow, that's terrible. I don't like that. Fireman style there. X minus 1. Kind of weird to put it that way, but so you got x minus 1 times x minus 1, and that makes it look like 1 minus x. But that is your x, and you're subtracting 1 off of it. So this side is x minus 1. And when you multiply that, you have x minus 1 squared for the square and you have 3 left over. And so that is your completing the square part. You've got a square plus 3. Well, if you notice, when we completed the square, by dividing by 2 and squaring it, we had a square plus 3. And so maybe that helps you. Maybe it doesn't. I'd appreciate any comments or questions that you might have, so you can tell me what I did wrong, or what really confused you about it. I hope it helps you. If it doesn't, let me know. I sure would love to change it. Have a good one. See you next time.